Okay, so now we're going to move on to exponential functions. So exponential functions is when you have a base a, and then you have a variable power x. So the variable is in the exponent. So what happens, instead of being like, say, x squared, it becomes something like 2 to the x power. This is what we call exponential function. So let's do something simple like evaluating exponential functions, alright? So let's say if you have f of x equals 1/3 times 6 to the x power. And we have x equals 2. So it's just to evaluate, okay? So we just plug in 2 for x. We get 1/3 times 6 to the x power, which is 2. Okay. So let's expand it out. 6 squared is 36. Alright, divide that by 3. Okay, we could either do long division, but I think what we should do is we should find the factors of 36. The factors of 36, since we'll get rid of 3, it would be 3 and 12. Okay, so the 3's cancel out, and then left over is 12. So that's not too hard. Alright, let's do something with graphing exponents, or I'll just kind of briefly go over kind of like a rough sketch of how exponential functions should look like. So for example, if you have, alright, let's just say in general a to the x, right? So if it's a to the x, and if a, alright, if this base a is, let's see, well, it can't be 0, but if it's greater than or equal to 1, actually just greater than 1, because 1 to the any power is just 1, so it doesn't really help us anywhere. Alright, then what happens is that the function looks like this. Alright, all exponential functions, they all go through this point right here, 1. At 0, it will always be 1, because a to the any power to the 0. So for example, like 1 to 0, or 2 to 0, or even 1/2 to 0. Anything to the 0 power is always going to be 1. Okay. Alright, so if you go towards the positive side or the right side, alright, the function increases like so. And then if it goes to the negative side, so if you have something like, like negative, let's see you have like 1/2, not 1/2, sorry, like 2 to the negative 1. What happens is that this becomes like a fraction, so the value gets less and less. So when you go to negative infinity, what happens is you're getting closer and closer to 0, but you don't touch 0. So this is how like an a to the x exponential function looks like. And then if you have, say, let's say if you had like 1/2 x, like that, okay? Then what happens is that your function actually, from the original, it flip-flops. So when you go to the right, you don't go into infinity, you go towards 0. And then when you go to the left, you go towards infinity. The reason why is this is a base that's in between 0 and 1. And if that's the case, what happens is when you plug in a negative number for x, what happens is this fraction flips and becomes bigger and bigger and bigger. But then if we put positive numbers here, this fraction gets smaller and smaller and smaller. So it goes towards 0. That's why it flip-flops.